Yes, oh yes, it's Uncle Jex, and today's video will be looking at the chromatography required practical. I'll first go through the theory behind the mechanism, then I'll jump on the practical itself, and then we'll look at a typical question you might get. Check out the timestamps below to skip to exactly what you need. Download the questions for today and also the answers for the previous video's worksheet as well. Alright, let's keep that tank. The type of chromatography that you need to know for GCSE is paper chromatography. In this technique, you will be using the differences in solubility to separate a mixture into its components. The mixture is usually a form of pen ink or food coloring. You have a piece of paper that does not move as the investigation proceeds. For that reason, it's called the stationary phase. Through this paper, there will be a solvent that will carry your different dyes along the paper. Since the solvent is moving, you've guessed it, we call it the mobile phase. If you're wondering why the dyes separate in the first place, wonder no longer. Uncle Jex is about to get all up in that. Let's first put ourselves inside the mixture of dyes. Due to the differences in their chemical structures, the different dyes have a greater attraction to either the mobile phase, which is our solvent, or the stationary phase, which is the paper. If they are more attracted to the mobile phase, they will move along with the solvent and so move higher up the paper. But if they're more attracted to the stationary phase, the paper, they won't move as high. And this, ladies and gentlemen, we get this lovely separation of dye on this paper. This paper with the separated dye has a special name. It's called the chromatogram, okay? With this chromatogram, we can now work out the identities of our different substances by first working out something called the retention factor. We work out our retention factor with this equation. Retention factor equals the distance moved by our substance divided by the distance moved by our solvent. Doing this gives us a number with no units, and this is the retention factor. Essentially, it's a ratio of how high your substance has moved compared to your solvent. You then use an online database along with your retention factor to identify your substance. Different substances will have different retention factors for different solvents. For example, something that's super soluble in ethanol might not be as soluble in water. When you're actually running your experiment, it's very important that you are paying attention to these steps, okay? Because there are some important things that you need to do to not mess up your results. The first important things that we must do is that we draw our start line around 1 centimeter from the bottom of our paper. And this has to be done in pencil. This is because if you use pen, the ink from the pen will interfere with your results and will smear everywhere. We don't want that. After we've drawn our start line, we add a drop of our solution where we're starting, so the start line. The next step involves you placing your paper in a beaker that contains your solvent. This is the next important part. You need to make sure that your solvent line does not start above your start line, okay? And the reason for this is because we want the solvent to soak through the paper and carry the dyes to their different heights. Now that your solvent is soaking up through your paper, you wait and allow the different dyes to separate. You should be careful though that your solvent doesn't go all the way to the top. That's because we want a defined solvent line, which is just the point where your solvent gets up to in your chromatogram. Remember our equation, the solvent line is where we get our number for the distance our solvent has moved to, that bottom number there. Now you draw a line that will be your solvent line and allow the paper to dry. The next thing you do is that you measure your distances for your different dyes that separated. You then measure how your retention factors look for your different dyes. I'll do one for you and you can do the rest yourselves. The solvent front is 12 centimeters and the blue dye moved 7 centimeters. Subbing these numbers into the equation, I get 7 over 12, which gives me 0.583 recurring. We want our answers in 2 significant figures, so that means that our full answer will be 0.58. pause the video and see if you can work out the rest of them. Let's pre this typical question. We have a chromatogram, but as you can see, we have more than one sample. The samples here are shown in the key. We've got caffeine, cocaine, ketamine, and urine from a sample of a horse. The first question asks us how we know that the caffeine is pure. Have a look at your chromatogram. We can tell that the caffeine is pure because from the start line, there's only one spot on that line, on that track, going from our sample 1. Therefore, it's likely to be a pure sample. Not gonna lie, this next one is a mad one. Why is there cocaine in the horse's urine? It's trying to be as high as a unicorn, I guess. Anyway, but it is still a 4-mark question, so let's take this serious. You better read the question carefully. You have to show you're working out and also look what it says here. Our answer must be in 2 significant figures. The first mark is for us extrapolating our values from the chromatogram. The drug moved up 4.2 centimeters and the solvent was 9.4. The second mark comes from substituting our numbers correctly. Because the distance to substance moves out goes at the top and the distance to solvent moves out goes at the bottom, that must be 4.2 divided by 9.4. The third mark comes from an answer, so that's 0.4468, and the final mark comes from getting our answer in 2 significant figures, so that will be 0.45. And that, ladies and gentlemen, is it for this video. Check out the work in the description, and if you're still baffed, use the timestamps to skip to what you need to. Like, comment, bell, and all that jazz. And don't forget that science is more than just a body of knowledge. More importantly, it's a way of thinking. Think big in a bit.